do it. All right, good morning, Circle City Con. Glad you guys made it to the first talk of Sunday. That's always the tough one. So appreciate that. This is a talk about automating malicious JavaScript deobfuscation. And to get started, just talk about the quick agenda. We're going to talk about the obfuscation techniques of, well, we're going to focus on rig, but these obfuscation techniques can be used across any type of JavaScript and can be employed to use to deobfuscate across different types of JavaScript. We're going to talk about the techniques, then we're going to talk about how you can find samples of this stuff. Manual analysis, I've got a lab machine here, we'll go through and do a little debugging. And then once we understand what we're looking at, just how we can automate that so that we can retrieve what is obfuscated automatically. So my name is Chad Robertson. I'm a security researcher. Why you care about this? Why I care about it? I think it's really fun to track threats. I think it's fun to track threats as they evolve. This stuff does evolve, but I find that it evolves fairly slowly, especially once you understand. Once I understand how a JavaScript works or how something works, it's typically a couple months it'll stay static, and then usually when it changes, it'll be just a little minor change. So then we'll have to just go in and make a quick tune to the script that's doing the automation. I think it's really fun. So I guess there's two main components of what can be gained from automating JavaScript deobfuscation, and that's adversary intel, what kind of payloads are being deployed, the type of, if like an RC4 key changes, which hasn't happened for a long time. So intel, and then also indicator discovery. So if we can find what the domains are, the URLs, then we can resolve those IPs, we can use those in our sims or whatever. Or we can figure out what payload's being delivered. If we're talking about exploit kits, but obviously, there's lots of other ways to employ obfuscation. Anyway, we'll focus on exploit kits for this. So starting with obfuscation techniques, there's a few of them. These are the ones that, I mean, there's tons of them, right? You can do anything you want to, but these are some of the ones that we're going to be looking at here. I'm going to be looking at this presentation, so I just wanted to highlight these. It's the word boundaries, minification, like minimizing code is like scrunching things together, and that's what beautifiers do. They kind of explode that out to make it look easier, make it easier to read. Adding spaces, white space, new line characters, those kind of things into the strings and into JavaScript to make it more difficult to see, analyze. Putting comments in, it just makes it more difficult to understand what the code is doing. Random variable names, so that's just a string, but and we'll see in just a second that you can use random variable names alongside of system function rewriting. And this is I think this is you may know what that's actually changing, what that variable is going to be equal to. Sub str. So it's just taking. I'm sorry. Is it fuzzy? It's just taking the string s and then hex 75. And then bs and concatenating that to tr, which is substr, and then it's making that variable equal to that. And then it uses that later in the code instead of using a subscript. And then integer obfuscation, just instead of 255 or like base 64, those kind of numbers that you do the math in the background are easy to identify, and like you can look at it and be like, well, that's base 64. So if you just do integer math, it makes it harder to see that. The XOR encoding, all different kinds, like base 64 we already talked about. Unicode, changing characters in Unicode, flipping things to hex, XOR, whatever, that's just XOR. It's just a random string. It's a HTML document that I XORed with deadbeef rotating key. So that's what that looks like. And then ASCII non-printable. So the script that we're going to be looking at in this presentation is the rig landing page, is current rig, and that's the data chunk, the data blob, and it's got all kinds of junk in it that has to be cleaned out. And you can see the ASCII non-printable, the A or 9D, over and over and over again. So that's it just makes it more difficult to understand what that data blob's doing. And then in the JavaScript, it's removed with the split function, which we can just duplicate in Python code. Okay, so finding samples. Where do you find this stuff? BT is a really great source, obviously. Pastebin and other websites, but we'll talk about the different websites you can get this from in a minute. Focus on BT for first. UR rules, is writing a hunting rule. If you have access to BT intelligence. This, I think I retrieved 116 different rig pages from this. And this was a slight modification. They changed the way the split function was in the code, so I had to change it a little bit. But just running that, once you identify what it looks like by going to malware traffic analysis or whatever website that has these samples, write a regular expression to identify it, throw it in a YARA rule, throw it up on BT, and hunt with it, find other examples, or once your YARA rule stops detecting, then knowing that you have to change it, figuring out what changed, updating the regular expression, and then continuing the track. Another place is like Pastebin. So stop here for just a second. Finding compromised sites is really interesting. So you find sites that are compromised. This is somebody's posted a bunch of compromised sites on Pastebin. Taking this list, feeding it into a sandbox, setting up a sandbox to churn these out, with some routine, running them on different browsers or from different IPs and VPN IPs to try to retrieve whatever is being hosted on these random sites, on these compromised sites, and then trying to shove that into the decoder, the automated decoder, to figure out what you get. Building that infrastructure is, Cuckoo's free, and this stuff is out there everywhere, not only on Pastebin, where people will post a bunch of compromised sites, but malware traffic analysis, Scumware, and a bunch of other ones. Just finding compromised sites, putting them in a list, pulling that stuff down, finding the things that don't look right, and then shoving them through a list of decoders and accumulating indicators. Another thing people do I think is really, really interesting, and when I first started I thought was really cool, is people whose sites get compromised will post questions about what this crazy PHP code is on their site to sites like Superuser. And they'll usually post a sample in there. And so you can just go on Superuser, or just go on Google and search for, virus, because like an admin that somebody has a WordPress site that they set up, and it gets compromised, they're going to go on some site like this and be like, as a virus on my website. And then you can search for like virus in WordPress or virus. And then once you see this stuff, then you can start seeing what it looks like, what that PHP code might look like, and then you can refine your search to find additional samples. And you can pivot. So once you get that data, you can either pivot in Google or pivot in VT, to find other examples of that same code that has been posted on websites, compromised websites, that are then doing the tier 2 connection back to where these kits are being hosted. That's all interesting stuff too. But that's not really the point of what we're doing here. We're just doing the landing page deobfuscation. There's a bunch of other sites you can get stuff. URL query, everybody's familiar with all these sites. These are all at the end of the presentation too. Okay, so manual analysis. It's always best to start with beautifying. I always beautify because it's usually a big chunk of junk that has to be cleaned up. Then remove junk code and then debug as needed. We'll go through each one of those. The beautifying step. Start out with what's on the left, and then run it through just an online beautifier. Turns into what's on the right. It still looks like it's a little hard to understand, but if you just spend some time on that and see that, like I don't have a pointer, but like that if statement, the if type of, that's undefined, so it's taking the U and sticking it to the U undefined, and then the GF, and then GF is defined right before that, so it's HND, and so that's making it a defined string, and replace is down there, and all kinds of other things that are peppered in. But in order to understand this, it's easy. You can go through that and figure that out, but it's easier just to go through and rename everything so that it makes sense, and it's really clear. And you can usually replace like multiple lines of junk JavaScript with things that are more interesting and more useful. So one point you can't, because this has non-ASCII characters, I try to use like JS-detox. I use JS-detox fairly regularly, but it doesn't like those, so it errors out. JS-detox is really cool. It just runs a little server just run as a server, and then you post your JavaScript in, and it'll analyze it, it'll beautify it, and then it's pretty neat. But it wouldn't work for that. So remove junk code. There's that, and you can change that to. I hope you can see that. I don't know. So that's going to change into the substring that we saw earlier, and so that so you can just make substring, give a substring instead. And then you see a for loop there, so the for loop has a bunch of random variable names and the replace REP plus LACE, and then a bunch of other junk, so you can change all that into things that are easy to read. So anyway, so this is the substring. The substring gets changed to substring. This is another. This is changing into. This is eval. Okay, so this is changing ET-RTA into the string eval. So then you can use the eval later on. It's evaling accumulator 1. You can clean that up just to say eval, right? And then so that just takes this big pile of junk data, junk code, and it cleans it up to look like that, which is much easier to read, and it makes a lot more sense. So the landing page that we're going to look at in this presentation has 3 loops and 6 chunks of data that are accumulated and that run through 3 distinct loop functions. And so we'll look at the first one, and then we'll look at a little bit of the second and the third. We won't debug through the second and the third, but we'll look at the first one mainly. But that's what it looks like after you clean it up a little bit. It makes it a little much easier to read. Let's see. So then, to do a manual analysis, replace the eval with a console log. Console log just prints it to the log, so it's much easier to see, or you can see it. What's this? This is the 3 loops for the landing page. This is the second loop, so it looks very similar, and you can clean it up the same way. This is the second loop, and then that's cleaned up version of the second loop. This is interesting. This is I don't think anybody can see that, but does anybody recognize by looking at that real quick what that's doing? I looked at that and I was like, what is that? And like the first time I saw it, but after you see it a few times, it's just this is base 64. But so that's really easy to replace in Python. And so this is what we end up with at the very end. So you have there's the key, and that's an RC, I think. It's an RC4 key, yeah, and then the URL. And so we'll get to that in the manual analysis piece and debug through and see that. And then this is the final loop, and it's the one that's responsible for the flash file, and so there you can see flash strings after you get through that debugging. All right, so demo. I was a little weird switching videos, so we'll see how this works. All right, so this is the beautified landing page. It's so you can see all the. Hopefully, you can see that. There's a data blob here. This is data that's inside, and I've renamed these strings already. So this is string 2 to make it easier to see. And you see the split function there at the end, string 1, and all the stuff that's being passed in string 1. The regular expression that's being applied to this data, the for loop, the accumulator loop, the undefined stuff that we saw earlier, and then there's a counter. So the counter is 3227. That's being used down here. And we'll step through this and look at it. And then we'll log it to the console log. So let's pop in the IE, run this. Maybe. There we go. All right, so to debug in IE, you just got to add the debugger semicolon string, and I've got a bunch of watches here on the right, which are all currently undefined. But as we step through, we'll see stuff pop over there. Close this one up, make it a little bit easier to see. All right, so we're right here. And then we'll F11 into this variable, F11 into that one. And then there's a regular expression. And let's see. So that should. I'm watching. No. F11. Alright, so that populated there. And then should be able to just put a breakpoint. Okay, there's already a breakpoint on the console. So basically we're going to step through here. It's going to do all that, and then it's going to break on the console.log. So let's just play this. Alright, and then we should look in the console, and then do a bunch of errors. And then once we step past that, I'll write that to console log. Alright, so there's the output of the first loop. And it's just, so that's the first layer. We've peeled back one layer of obfuscation, and now we've gotten to the second layer of obfuscation, which looks like this. So what we can do is, instead of doing debugger, let's restart this. I'm going to go change that to, let's turn this to eval, and we'll go inside there instead of just going over it. Save this. Restart IE. Go into debug mode. Open the file, maybe. Working, open. Okay. And then go down to where we were, where we care, and then there's our new file. So we'll play until we get to that eval accumulator. We'll step into that. And now we are inside of the eval, and now we can go through this second layer. Okay, so looking at the second layer, we see that base 64 encoding code, and then we can see we return R, which we'll just jump down and return R, which we don't have any breakpoints before that, so let's play up the break to return R. There's that. Now we can look at R and see, let's see, copy, new tab, paste. Alright, so there's what R looks like after the second layer of decoding. And it's starting to make more sense now. So you can see that this is a VB script. And it's got a bunch of new line characters in it and stuff, but it's a VB script. So, we understand there's two layers of this obfuscation. There's a VB script. Now we get to the VB script. The VB script needs a little bit of cleaning up because you have to take the new lines out and format it a little bit. But now we've got something interesting. So we now have a key. We have our RC4 key. This RC4 key you can search, and it's been the same for a long time. And then there's the URL. That's to the URL that we care about. And then there's also a stub code. So there's this DLL variable, DLL code. And so what it does is it, let me see if I can find one that's been beautified, because I don't have internet access here. Beautified second layer of VBS. Maybe we'll see that. Yeah, okay. So this is it's pulling down, it's basically taking this, the text from this, and it's concatenating it with this header, which is, it's concatenating with this header, and then it's making the payload. And so we can look at that. This thing has frozen twice since I've been standing here, and it hasn't frozen for a long time. But it made it through that far, so that's good. Anyway, so that's the header. It takes the header, it downloads the URL, and then it sticks them together, and then that's a payload. And then you can track payload by doing that. All right, so we got that far. Let's switch back over to, we've really got everything we need. So we understand how to deobfuscate layer 1. We understand how to deobfuscate layer 2. We understand what we want. We have a URL variable that is interesting. We have a DLL code variable that's interesting. And we understand how those layers are obfuscated, so we can just pull those out. So switching back over here. So now how do we automate this? So now we've got a sandbox set up. We're pulling all these down from compromised sites. We know how they work. We've beautified it. We've understood the code. Well, I mean, data into obfuscation routine equals obfuscated code. Data into deobfuscation routine equals deobfuscated code. So how do we do that? We step through each piece and deobfuscate it. This is super small, but okay. So we have to find the variables, the data blobs. We have to find the data blobs, and so this is just a regular expression that's doing that in Python. So on the left you see the script, on the right you see the Python output, and it's got the variable name there at the top, and that's how you do it. Next down is taking out it's doing the split. So there's the first split, and then after cleanup on the right, so you see we no longer have those non-printable, the ASCII non-printable characters. There's the regular expression, and then we can apply the same regular expression in Python with that function that's defined there. Automation for loop. So there's the for loop in the code, and we can do the same thing in Python with those two loops. Base 64 is super easy. So that's how we do it in base 64. Decode that, and then that's it. So let's look at this code. Hop out of here. Maybe, maybe. There we go. Give this a second. All right. Okay, so you can see that. So clear screen. Okay. So inside this ls-la, there's a bunch of files in here. In the bin file, there's an LP decoded. That's the output, the eventual output. There's an LP text. Let's take a look at that. So let's look. What is it? LP.text. Yeah. So that's what we were seeing before. It's a bunch of junk. This is the data blob that we need to clean up. One of them. You can see the first split there under that string. There's another data blob. There's the undefined string, the eval stuff. So that looks familiar. This is what we're looking for. Let's see, there's the rig decode Python script. There's the, and then there's a stub. And so let me rm the stub, and then rm the LP decoded. We're going to make those again. And then let's see, there's LP text, rig decode. Okay, so then let's the Python script. And I mean, it's not too terribly long, but that's pretty much what we're going to use to decode this. And we're just going to do exactly what we just saw. We're just going to reverse it. And I put a bunch of comments, put a bunch of pauses in it, so we can see each time, like each step, and we can see the different layers. So we'll just go through it and see. But you run it by just doing Python -lp, and then giving it to the landing page.txt file, I guess I gotta say the reg decoder script. All right, so and I just put little debug messages in there. So this is the data strings that we're pulling out with the regular expression. And we should be able to go to the top and see the same thing we've already seen. Super long. Guess we can't. But anyway, that's the data strings. There's the counter. That's a string. It's also regular. Just regex out of the data of the file. There's a split value. So yeah, there's the split value. And then if we take that, there's the. So now we're taking one specific variable, the first variable, and we're gonna take out that was it A9? We're gonna take that out of the string, and then so there's the cleaned up first data blob. We haven't done anything with it except remove the non-printables, and it's starting to look a little bit more sane. Let's see. The regular expression needs to be cleaned up a little bit. So this is before the regular expression cleanup, and then after the regular expression cleanup, and I think we apply that. Yeah. So we apply that regular expression to the data, and then now we're ready to do the layer 2 deobfuscation, which is just the base 64 layer. And so you throw that base 64, decode that, and then you get the VB script. That's right there. Go to the top here. And it's just pretty clean and easy to figure out what this is doing. There's various DOM stuff in there. There's the URL, there's the key, what we're looking for, and then there's the DLP code array. This script also takes that out and builds the stub out of the DLP code variable so that you can then use that URL and that stub to build the payload. And so that should now be in the /LA. That should now be in this folder, which it is. So XXD stub +. There's our standard PE file. And so we see the PE header, the resource sections, and there's a few function names, I think, in here. Yeah. Create event stuff. And I looked at this. You can look at this on VT, and I think somebody called it server and some other stuff. Let me see. But, I mean, that's just the stub. It's not. Let me find the VT tab. Anyway, you can MD5. You can do an MD5 of this and search for it. Somebody's already done this and uploaded it. MD5 sign. MD5 sign. Yeah. And then you can look at that. So, and then if we look at the landing page decoded file, we get the Visual Basic script and then the stub file. So that's really what we want. We want to be able to automate all this. We want to be able to take an obfuscated script. We want to pull it through automated means, pull it through scripts, pull them down, accumulate them, and then slam them into a Python deobfuscator, decryptor, or whatever. Depending on, if you're going to do the payload decryption, you would have to apply the key. It's a RC4 key, so you have to take that key and apply it and decrypt the payload that's being downloaded from the URL and then to build payload. But you can pull a lot of really interesting stuff by doing this. So that's that. Let's go back over here. I think I went really fast, but that's really it. That's 37 slides. That's insane. That's what I get for going really fast. So that's it. There's a project out there called Malgetter that I found when I was doing this. I mean, and it's really cool because it's currently updated. There was an update 3 days ago. There's various. So there's threads. There's a campaign. There's a rig thread. There's a rig campaign, and inside that campaign there's various threads. There's like I don't even remember the decimal IP, Goodman, EI test. Those different threads that are inside of that are operating in rig right now. Malgetter will help with each one of those. It's a tool that analyzes those, and I think it outputs. It's kind of hard to see on this one, but I just found it before I came in. I thought it was really cool. So go check that out. There's also, and it's by the NAOSEC person. That person, there was an RSA shadow something that was posted recently that talked about rig and talked about the different campaigns, the different threads that are going on in rig. That mentions this guy. And so, anyway, that's really cool. Check that out. And then that paste bin that I posted earlier with the compromised sites, that's there. Tab the Hermit has a rig decoder. I don't know that it works. I tried to use it on the landing page that I had. It didn't work, and obviously they change every once in a while. I'm not sure how often his has changed. His is updated, but there's a rig decoder that he has. There's also another one out there that's out on Git if you search for it. Node.js is a product that's for doing deobfuscation automation, and then there's a couple other resources there. So yeah, sorry that was really fast, but there you go. That's the thing. Anybody has any questions? Obviously, I have plenty of time to talk about that. So yes, sir. Yeah. It did? Nice. I love JS Detox. And that's a good tip. Thank you. I used to use it a lot, but just the non-printable doesn't like those. But that's great. And it did the whole deobfuscation for you, and you just changed the. So yeah, JS Detox is good stuff. Anything else? I'll hang out here for a little while if you guys want to come up, and I can walk through any of this stuff. Happy to talk about it. So just let me know. Thanks.